Hello, I'm Saurabh Kumar Dutt and I'll be discussing about solving trigonometric equations in this lecture. We will be looking up what equations are, and remember, I'm going to tell you some real stunning facts. Then we'll be discussing what actually trigonometric equations are. Then after that we'll be talking about how to find out the different type of solutions which are possible of a trigonometric equation and what are their limitations. Then we'll also be looking up a special sum which is going to discuss all of these things that you learned in that sum. So be there, weld yourself with the seats where you are seated, and make sure that you are there till the end of this lecture so that you can absorb everything, understand every concept, and I can tell you that you're going to be refreshed. You will have such knowledge that you will be able to apply it to most of the sums on trigonometric equations and thus become a pro. So let's get started, children, and let's quickly discuss what an equation is. An equation is actually an algebraic expression which somewhere the other in between or probably at the end has an equal to sign. For that matter, if suppose we talk about an equation, it can look say something like this, that is say some 4x cube minus 13x which is equal to say some 17x square minus 23, right? This is just any equation. So as you see that there is actually a equal to sign in between, so you can directly say that this is not just an algebraic expression, but this algebraic expression has been converted to an equation. So an equation primarily means that there are two sides of it and both of the sides are equal. So here if we keep the value of the unknown variable, that is x, and we find out the value of the expression on the left hand side and we find out the value of the expression on the right hand side, we will find that both of these values will come to be equal. So this is the speciality of an equation. Now normally when you have an equation, what you do is you bring everything to the left hand side, right? So we have 4x cubed, and then after that you write the terms in the order of the indices which is descending. So we have 4x cubed minus 17x square minus 13x plus 23, right, which becomes equal to 0. So this is an equation which is normally formatted. And now here, what do we require to find out of an equation? We require to find out those values of x, right, or any variable which are possible, which will make this equation to be always true. So here, as everything else is on the left hand side and on the right hand side you have 0, as such, when you get a solution and when you put it up in this equation, you should be able to get 0 on both the sides, right? Okay, now can you tell me some speciality of an equation? We've already discussed what an equation is, right? And we also have it in front of us. Now can anybody tell me what is the speciality of an equation? Looks to be pretty simple question, but there is depth in it, and I know that you know it. Just try reflecting. No? Well, let me tell you. An equation is such an algebraic equation expression which has a definite number of solutions. For that matter, here we have the highest power of the variable to be 3, right? And the others are less, as you can see. We have 2, we have 1, and we also have x raised to the power 0, as x raised to the power 0 is 1. So 23 actually has x, but the power of x is 0. Now as the highest power of the variable is 3 here, so we expect a definite number, that is 3 number of solutions from this equation. So this is the speciality of an equation, that is in an equation you have a definite number of solution and that depends upon the highest power of the variable. Now contrary to that, if you talk about in an inequation, you actually won't be getting a definite number, but that can be say varying from no solution, that is a null set, or probably infinite solutions. So you can't predict the number of solutions that you can be getting from an inequation, right? That is an inequality. Something like x square minus 4, right, is greater than or equal to 0. Okay, so here now if we talk about an equation, we are fully clear. Now, to be able to have a trigonometric equation, we just require to change the variables to be now just the trigonometric ratios. Now, what are the trigonometric ratios? I'm sure you people know that we have 6 trigonometric ratios: sine and its inverse cosec. Then we have cos and its inverse sec. Then we have tan and its inverse cot. Right? Now, if we talk about these are actually trigonometric ratios, and they are incomplete without what? Without the angle, right? So here we can take the angle to be, say, some angle theta. So as such, here theta is the angle, and when you know this angle, then only you can find out the value of these trigonometric ratios. And these trigonometric ratios are now going to replace the variables in an equation. Now, children, one thing that you have to be cautious about is that when we talk about a trigonometric equation, it will be having trigonometric ratios, and you can't consider sine theta and sec theta to be just like x, because if you keep the value of theta, sine theta is going to come to be different and sec theta is going to come to be different. As such, the complication now comes if theta is the only variable, but you have different trigonometric ratios. As such, there'll be more number of variables. For that matter, let us consider that we now have a trigonometric equation where, let's say, we have something like 4 sine square x minus 3 cos x plus 2, which is equal to 0. So here, children, you get to see that this is actually an equation where the variable is a trigonometric ratio, something like sine theta, cos theta, etc. Right? And we actually don't have to find out this trigonometric ratio. Our task is actually to find out the angle which is associated with this trigonometric ratio. And it is not important as to which trigonometric ratio you use to get it. That means you can get the value of x using cosec, or you can even get the value of x using tan, but it doesn't matter. What matters is what is the value of x which will satisfy this equation. Did you all understand? So, excuse me. Now, one thing that I told you, that is, if you talk about sine x or cos x, you can see that they are actually two different variables, because the moment you keep the value of x, let's say 60 degree, you will have sine 60 to be different and you'll have cos 60 to be different, right? And thus you have different strategies which in times to come I'm going to tell you that you apply so that you can actually solve a trigonometric equation which has more complexities than a normal equation, right? Okay, now to come to the point of when you will find out the values which satisfy this equation, that is a trigonometric equation, what is actually the type of solutions that you should be expecting. So here, children, we have some special type of solution that we expect. That is, the solution can either be a solution which is normally possible, right? And then you will have a solution which is for a specific case, and then you will have a solution which is generally available, right? So the solution which is normal, that can just very easily be thought about, that is known as the principal solution, right? Repeat with me, it is not PLE, it is PAL. So this is one of the solutions that you have when you solve a trigonometric equation. Now the second solution that you can be expecting will be a specific solution. Now when you talk about a specific solution, it is actually a solution which exists between a range of values which has already been provided to you in the question, that find the values of theta within this range. Then obviously for that specific question, that will then become the answer, right? Now after the children, now next we talk about the third type of solution that we want to find out, and that is actually why you study this chapter, that is the general solution, right? And when you talk about the general solution, children, then this is that solution which has all of the other solutions automatically in it. right? Thus, in the language of sets, we can say that the general solution properly includes the specific solution and the principal solution. Okay, now children, let's get ahead and try out some sum. But before that, obviously, like I always do, I will not let any confusion stay. As such, I'll be discussing all of this all over again, so that if there is something that you haven't understood, or probably something that was left out by you or probably by me, we will revisit and ensure that there is a proper understanding of the concept, because only when the concept is very well understood, then you can go about with the sum and get to the solution. Okay, so here children, we have this topic which is solving trigonometric equations, and in this the two primary types are actually the principal and the general solutions. This is actually what is normally asked by the examiners. Specific solution is hardly the case. So whenever we have an equation, it is actually an algebraic expression where in between somewhere, or probably at the end, you should be expecting that there is an equal to sign, which actually depicts that whatever is on the left hand side of the equal to sign and whatever is on the right hand side of the equal to sign are both equal, right? Next, when we talk about a trigonometric equation, we actually mean to say that this variable is actually to be replaced by a trigonometric ratio, and then whatever equation you get, that will then become a trigonometric equation. So a trigonometric equation is primarily a equation where in place of the variable you have a trigonometric ratios. Like you know that there are 6 trigonometric ratios: sine, cos, tan, cot, sec, cosec. So any of these 6 trigonometric ratios can be here in place of the variable x, right? Now after this children, next we will be talking about, say, a trigonometric equation which is just like 4 sine square x minus 3 cos x plus 2 is equal to 0. Here children, we get to see that in place of the variables like x, we now have what? We now have here sine square x, we have cos x, right? And there is one more complexity that I told you about. Can you tell me? There is a gift if you can tell me correctly. Well, let me tell you. If you talk about sine x, it will come out to be a different value, and cos x will come out to be a different value. X obviously will remain to be fixed. It can be, say, something like 30 degrees, but cos of 30 is different than sine of 30, right? So as such, here you just don't have one variable, but you have 2 variables, right? So we have to apply some strategy, which you'll get to see in times to come, that we'll apply so that you can get to the value of the angle with the least complexity. And remember, the angle here is this x. It can be replaced by any of the Greek alphabets like alpha, beta, gamma, or probably it will remain to be the latter English alphabets like x, y, z. Now whenever you have a trigonometric equation, actually there are 3 types of solutions which are possible. The first is the principal solution. That is the solution that you generally will get, right? And here children, I will tell you one thing more, that if you talk about the principal solution, you have to remember that this value of theta that you try and find out is to be in angle about a point, that is from 0 to 2 pi, and here we're considering the angles in radian. So from 0 radians to 2 pi radians will actually give us all the angles which will give us principal solution, and for every case it's going to be different. Now specific solution will obviously be in a range of values. So you will be given a range of values, right? Let's say you'll be given, say, from 0 to pi, and in this range you will then have to find out the value of x, and then obviously there can be multiple stipulations, like here I have removed the equal to sign. So then in that range, whatever solution you get, that then is going to become the specific solution. Now finally we have the general solution, that is the solution which you will get to under any circumstance, right? So there can be different circumstances, but if you talk about all of the solutions which are possible, then it can be generalized with this expression, and that is known as the general solution, which in times to come we are going to look up. I hope all of this is clear. For sure. Shalini? Really? Well, rest of the class? Robert? Good. Now children, after this, just hold your breath. There is a sum which is going to come your way, and all of this that you've learned, I expect you people to pause the lecture, write it all down, even though if you know it, and then write it once again all on your own, right? And after you have confidence in that, then get to the sum. I will give you just 10 seconds for trial. However, you can take an elongated period, you can try out for a longer duration of time, try get to the answer, and then look at the solution. You will feel much more comfortable even if you've done the sum or not done the sum, right? Now after you've understood the solution, then I again expect you to pause the lecture and do the sum all over again, all on your own. If you can't, if you have to look up the solution once, then you should do the solution once more. Okay children, with all of this said, let us quickly now look up what the sum is. Right, so children, this is the sum that you're going to try, and like I told you, I'm going to give you 10 seconds for trial, right? I know that that is not apt, so that's why you can take a longer duration of time by pausing the lecture, and trying out the sum first is something which is mandatory. Not just does it quickly revise the concept that you just learned, but it also helps you in critical thinking. So you will try thinking hard, and as such you will be able to learn simple inner concepts which when applied you'll be able to do a sum, right? And if you can't, then even then when you look up the solution, you'll be able to understand more in depth, right? My primary intention here is to help you out, and that is why I devise such strategies which will actually help you out to do any sum which is before you. Okay, so here children, in the sum we have to find out the general solution of 3 tan theta plus cot theta, which is equal to 5 cosec theta. Now can anybody tell me from what all I told you, or what is the thing that we can get to see? Anybody? Very correct. You can get to see that there are actually 3 variables. The first variable that you can talk about is actually x, which is tan theta. Then we are getting to see that there is another variable that is y, that is cot theta, because its value is going to be different. If cot theta say is 1/3, then say tan theta will be 3. If tan theta is 4, then cot theta will become equal to 1/4. So obviously there are 2 different values, right? And finally you will have another variable which is z, right? So our task is first to reduce the number of variables so that we can solve out this equation simply. So what is the first thing that we can do is trying to reduce the number of variables. We will actually convert every trigonometric ratio in terms of sine and cos. So the first thing that we can do here is we will write this to be 3 times of sine theta, which is divided by cos theta, and to that then is going to be added cos theta, which is divided by sine theta, and further children, that is going to become equal to 5 times of 1/sine theta, which actually is the value of cosec theta, right? So after we have all of these, next you get to see that now there are just 2 variables which are left out. The first variable being this, just like x, and the other variable being just like y, that is this, right? So now we have replaced 3 variables to be just like 2 variables. Now our task further should be what? It should be to further reduce the number of variables and get it to just 1 variable, right? So next what we're going to do is we will now try to do something such, and here children, as you get to see that there are fractions, so we're going to take an LCM. So that is the step that we'll be writing here. Whatever step you take, do write it. So here we'll be taking LCM, and here too you will get to learn something brand new, I can assure you that. Okay, so here children, when we take the LCM of these fractions, we get to see that the first 2 fractions denominators are different. So as such we will multiply these 2 different numbers, that is cos theta and sine theta, and in the numerator you will get to see that you will now have 3 sine squared theta, as this sine theta cos theta is going to be divided by cos theta to get sine theta, which will get multiplied to sine theta to give you 3 sine squared theta. Now after that again we do the same procedure, and now we have plus cos squared theta here. Next after this is equal to 5, which is divided by sine theta. right? Okay, so this is after taking the LCM. Now, is there something special that you will really pop up and try to do? Yes, you will try and cancel off the sine theta, right? This is normally what you like to do, and I'll rather cancel it for you. So what you like to do is cancel the sine theta off so that you can simplify things, right? This is what you will do. Yes, you will do this, but actually you shouldn't be doing this, and why, I'll show you now. So here, children, there is one thing that we can do. We know that if we talk about sine square theta, excuse me, plus cos square theta, we know that its sum is equal to 1. As such, here in the numerator we can apply this, that is, we can write this as 2 sine square theta, to which sine square theta can be added, right, and further to that can be added cos square theta, right, and now in the denominator you can be having cos theta sine theta, and that, children, further is going to become equal to 5 upon sine theta, right? So when this happens, then again sine square theta plus cos square theta can be written to be 1, as you already know it. So we will be replacing the value from the above equation that we have, and thus we will have 2 sine square theta, which is going to be left out, and to that is going to be added 1, which is the value of sine square theta plus cos square theta, and that then is going to be divided by cos theta sine theta, right? And then after that we also have this 5 upon sine theta, which is there on the right hand side. Now I'm sure you people must be having a pop-up from your head, why not cancel off the sine theta, why not cancel off the sine theta? No, don't do it. I'll show you why. Now next step is what we do say to be cross multiplication. So when we cross multiply, we will bring everything to the left hand side. So we will now have sine theta, which is going to get multiplied with 2 sine square theta, right, and to that is to be added 1, and on the other side we will now have 5 times of cos theta sine theta. Now after that, next what's going to happen is you have terms on either side of the equation. Why not bring all the terms to one side of the equation? Probably the simplification will become simple. So here, children, you have sine theta times of 2 sine square theta plus 1, right, and from that you subtract 5 cos theta sine theta by bringing the term which is on the right hand side to the left hand side. Now the fun, you get to see that in both of these terms you actually have sine theta, which can be taken common outside. So as such, you will take the sine theta common outside, and that is precisely the reason why I did not multiply the sine theta within, because I was able to see that in the next step sine theta can be taken common outside. Now further here you'll be left out with 2 sine square theta, right, plus 1, from which is subtracted 5 cos theta, right, and this is equal to 0. So for the children here, we can further simplify and write this as sine theta, right? Just try seeing something. I'm going to ask you that special peculiar question, what is it that you can see, right? So while I'm writing this step, just try and see something and feel yourself to be apprised entirety. So you have 2 sine square theta, right, from which is subtracted 5 cos theta, right, plus 1, right, which is equal to 0. Yes, what is it that you get to see? Can you tell me? Well, let me tell you. Here you get to see that if you talk about this sine theta, by cancelling it off earlier, you would have wasted it. That means it would have got vanished. But whenever you have to talk about an equation, you can't get rid of any of the expressions which actually have the variable. For that matter, here we can be having, say, something like this, that is, say, some x square minus 7x, which is equal to 3x square plus, say, x cube, right? Now in this algebraic equation, what you can do is on the left hand side you can take this x to be common outside, right, and then you will have x minus 7, which is left out here, and on the right hand side again you can take this x square common outside, and then you will have 3 plus x, which will be left out, right? Now if you cancel this common term on either side, you will now no more have that x, and that x is going to give you in times to come one of the roots, that is the values of x. So every power of x actually is very important, as it gives you a specific value which satisfies the equation, right? So here, in a similar way, what we do is we will not be cancelling of the sine theta when we can, right? And now you can either put sine theta to be equal to 0, or you can also put 2 sine square theta minus 5 cos theta plus 1 to be equal to 0, right? So here, children, we will be applying the zero product rule. So the zero product rule is what? Tell me. No? Well, let me tell you. If you have some a which is multiplied with b and their product is equal to 0, so you can say that either a is equal to 0 or b is equal to 0. Then you can say that either you have the value of a to be equal to 0, or you can say that b is equal to 0. Both of these can be true. But saying that both are equal to 0 is something which will be inept, as that will tell you that both the answers are 0, and that is something which is crude, right? So this is the assumption with which we'll move. As such, now next what we're going to do is we will put first sine x to be equal to 0, and thus we will say that when we have the value of sine, right, that is, we will say that when sine theta is equal to 0, we know that this is going to happen when we have angle 0, right? That is 0 radians or 0 degrees, whatever. In that case, we will get the value of sine to become equal to 0. As such, here you get one value of theta that is 0. And like I told you, any value of theta or that of the angle, right, when you talk about the angle to be varying between what? Varying between 0 and 2 pi is going to be said to be the principal solution, right? I'll show you this now. Can you see here, children? Here we talked about the value of theta to be varying between 0 and 2 pi radians. Then it is known as the principal solution. So this value of sine that we've got to be 0 is actually forming the principal solution because it is in this range, right? Okay, now getting back to the sum, right? So here now, right, so here, children, you get to see that we have got a principal value for sine, right? And you will say here that the principal value obtained is how much? The principal value, one of the values of the angle theta is 0 radians, right? That is what we can say. Okay, now we come for the general solution. Now for the general solution, children, there is a rule. If we have sine of angle theta which is equal to 0, right, then we get the general solution, that is the value of theta to be equal to n pi. Now children, this is a rule, right? So whenever you keep the value of n to be any positive or negative integer, you will get all the general values of theta, right? And when sine theta is equal to 0, then the general value of theta by this formula is going to be n pi, right? Now I require you to mark this, right, as one of the answers which is possible, right? And as such, here we'll be talking about this to be one of the answers that we've got, right? Obviously, if you talk about the principal value, that also is one of the answers, right? So this principal value is also one of the answers, as remember we had to find out the principal value as well as we also had to find out, right, what value? We also had to find out the general solution. So this actually gives you the general solution, right, and the above is the principal solution. Now remember, children, we also have another part which is left out, and now we're going to talk about it. So if, say, we now talk about the second part of this equation, we still by zero product rule are going to put up 2 sine square theta minus 5 cos theta plus 1 to be equal to 0. So 2 sine square theta minus 5 cos theta plus 1 is equal to 0. Now quickly checking whether all of this is correct or not. So you have 2 sine squared theta, and then you have minus 5 cos theta plus 1 is equal to 0. Perfect. Now you have to solve this out, right? Because this is also one of the solutions which could have been possible, right? So here you will say that if this is equal to 0 by the zero product rule, then what will you do? Now children, remember again, we are going to use the trigonometrical identity. That is, if you talk about sine squared theta, and to that if you add cos squared theta, then their sum is always going to be the unit number, which is the multiplicative identity, that is 1, right? And here children, what we'll do is we will write the value of sine in terms of cos. As such, we can now say from this equation that we can have sine squared theta, which can be written to be equal to 1 minus cos squared theta. And when we write this children here, we will have this equation now getting converted to 2 times of 1 minus cos squared theta, right? That is the value of sine squared theta, and from that is going to be subtracted 5 cos theta, right? And to that 1 is going to be added, and the sum of all of this is equal to 0. Next children, we just require to simplify this. So this is then going to become equal to 2 minus 2 cos squared theta, right? And minus 5 cos theta is equal to, plus 1 is equal to 0. Now when you get to see this equation, should you feel overjoyed? Should you feel happy, or should you feel unhappy? You should feel happy. That is because now you do not have two variables with two different trigonometric ratios where the angle is the same, just like sin theta, cos theta. You actually have just one variable, just one unknown, and that is cos theta. And when you solve this out, then you will get the value of theta, as one of the solutions is going to become the principal solution and the other is going to become the general solution. Okay, here children, next what we do is we can now have this to be the quadratic term written first, that is minus 2 cos squared theta, and then is minus 5 cos theta, right? And then you have 1 plus 2, which becomes equal to 3, which is equal to 0. Now this thus becomes a simple quadratic equation, just that the variable in place of being x or y is actually cos theta. No problem. Now children, here we get to see that if we write the product of the prime factors of the coefficient of the quadratic term, which is 2, and the constant term, which is 3, we can get to 2 plus 3, which is 5. But in that case, we will have to write minus 2x minus 3x, and that will then become 3 minuses and 1 plus, which actually cannot be factorized. And that is why we've got to devise some other rule. What we can do is we can now write this to be 3 into 2, which is 6, and we further multiply that by 1, and thus if we write minus 6 plus 1, that will again give us minus 5. And this is going to be fine because we will now have 2 terms with plus and we'll have 2 terms with minus. As such, this is perfectly fine, right? So now next what we do is we will now write this as minus 2 cos squared theta, and then we have minus 6 cos theta, right? And then we have plus cos theta, whose sum will become equal to minus 5 cos theta as is required, plus 3, which is equal to 0. Now from the first two terms we have a minus 2 cos theta, which can be taken common outside, and inside then you'll be left out with just cos theta, right? And then plus 3, right? Now children, when you write cos theta plus 3, right, this is the other binomial, right? If you multiply this with plus 1, you'll be able to get cos theta plus 3 as required, and the sum of all of this is equal to 0. Now children, this polynomial in the last step has now become a binomial in this step. Now you can further make it a monomial by taking this cos theta plus 3 to be common outside. So you have cos theta plus 3, which is taken common outside, and inside then you are left out with minus 2 cos theta plus 1. And as you see that this has become a monomial, so this stands factorized. Now that this is factorized, again you will have to apply the zero product rule, right? So here you will say applying 0 product rule, right? And when that is applied, children, you know this, that once we will have cos theta plus 3 to be equal to 0, and at the other time we will have minus 2 cos theta plus 1 to be equal to 0. So here, children, we can say that when we have this cos theta plus 3 to be equal to 0, we will get the value of cos theta to be equal to minus 3, right? Now, what value of theta corresponds to this? Who can answer this to me in the class? Yes, take your chances. No, 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 just not. Well, let me tell you. If you talk about the value of cos theta, children, remember that cos theta varies between two values, that is minus 1 and 1. Never is it lesser than minus 1, nor is it ever greater than 1, right? So this value that cos theta is equal to minus 3 is actually a value that we can never consider to be correct. That is, this is an incorrect value, right? As such, this value of theta, which gives us cos theta to be minus 3, is actually an absurd answer, right? So now, children, next we come over to the other term, that is minus 2 cos theta plus 1 in applying the zero product rule. So we will say here that when we have this minus 2 cos theta plus 1 which is equal to 0, so what we can do about this is we can now take the 1 to the other side. As such, we will have a minus 2 cos theta which will actually become equal to minus 1. So here what will happen is minus signs will get cancelled from both the sides, and you will get 2 cos theta to be equal to 1. As such, cos theta is going to become equal to 1 upon 2. Now, when is it that cos theta is equal to 1 upon 2? That is when it is 60 degrees, or in other words, we can say pi by 3 radians. So here, as such, you can say that cos theta is thus equal to cos of pi by 3 radians, right? Radians, you either write it or you don't write it, doesn't matter. If you have not written it, it automatically means that this angle is in radians. Okay, so cos theta is cos of pi by 3. Thus, you got a principal value, right? So here, children, if you talk about the principal value, then what is it going to be? Yes, it's going to be pi by 3, right? So that is going to be one of the answers, right? Is that all? Yes. No, that is not all. That is because if you talk about cos at another point in the 4 quadrants, it's going to have a value of 1 upon 2. That is when we talk about cos of minus pi by 3. Let's look up this formula. In times to come, you will study this formula. Probably you already studied it. That is, when we talk about cos of minus theta, this angle falls in the 4th quadrant as theta is acute. This becomes equal to cos theta, right, as in the 4th quadrant cos is positive. So if you talk about cos of minus pi by 3, thus what you will get is you will actually be able to get to this, that cos of minus pi by 3 will become equal to cos of pi by 3. And what is the value of cos of pi by 3 that we just looked up? 1 upon 2. So another value which is possible is going to be how much? Minus pi by 3. And since we are talking about the angles to be from 0 to 2 pi, so now we will try and write this minus pi by 3 to be in terms of the angle when we are actually moving just anti-clockwise direction, right? So here what we can do is, let's just try and consider what I'm trying to tell you. That is, if we now talk about, say again, the 4 quadrants to be made something like this. This, say, is the vertical line, and then now we are going to have the horizontal line, say something like this. And now, children, if say you talk about here this angle that I was talking to you about, that is minus pi by 3, right? So this angle was minus pi by 3, which is the same as minus 60 degrees, right? So if you try and approach this, so if we talk about this, right, we can say that this actually corresponds to an angle which can be written, say, something like this. Just a second, guys. All right. Okay, so let me draw that straight line again. So if, say, we talk about this straight line, it actually is going to be something like this. So there's one thing that you can see, that if you talk about this angle which has been got by moving in the clockwise direction, that is 60 degrees, and if you actually move just in the anti-clockwise direction, this angle you know as how much? 3 pi by 2, right? And to it, if you add 30 degrees, as this angle is already 60, you will be able to get to this angle. So this angle is actually what? It is actually 3 pi by 2, to which you add how much? You add 30 degrees, which actually is pi by 6. So when you calculate this, this is going to become equal to 2 into 6, where we are going to take the common factors. So of the first you will take 2, and of the next one you will take the uncommon one, that is 3. So as such, the LCM becomes equal to 2 into 3. So now this numerator is going to be multiplied with 3, so that will become equal to 9 pi, right? And to that is going to be added here just pi. So children, this is going to give you how much? This will give you 10 pi by 6. Obviously there is one common factor in the numerator and in the denominator, and that is how much? 2. So 2 3s is 6 and 2 5s is 10. So as such, this angle is going to become equal to 5 pi by 3, which is another principal value that we can be having, right? So pi by 3 and 5 pi by 3 will be the two principal values that we can be having. And now children, we'll put this in a similar sort of a box. This is not a tomb, but this is a box which actually shows that this is the value with which we are concerned, that this is the answer, right? So these are the principal values found out. Now after the principal value, we now have to talk about the general value, for which I'll have to tell you something special. Now just look up. If you talk about when we have cos of theta, which is equal to some cos of alpha, where alpha is any angle in between 0 and 2 pi, then children, what we do is we have a formula. We get the general value of the angle, right? So you can say that the general value of the angle theta will be given by a formula, which is theta is equal to 2n pi plus minus alpha, as alpha here is the angle. Now in our case, what do we have is we actually have cos of this angle theta, which is equal to cos of either pi by 3, right, or we have it to be 5 pi by 3. As such, we can now write this theta to be having a final general value to be how much using this formula? Yes guys, everybody together. That's theta to be equal to 2n pi plus minus pi by 3. Right children? So this is another answer that you'll be having. And now we'll again put that in a box which just looks like a tomb, but it is not, remember, right? Okay, so this is another value of theta, the general value, right, from this case. So that is all that you're going to do in this question. Remember, one of the values was defunct, which was absurd, and that's why it wasn't taken. So all of this I'll just quickly discuss again, so that if there is any doubt you have at any point, we will discuss it again. Moreover, if you have any doubt, right, then you can even write to me in my comments, or you can just write a mail in saurabhkumar@gmail.com or the mathematicshelpline@gmail.com, right? For that, you can even fill up a form that is there as to tell what your specific problem is, and you'll find me coming back to you and discussing it. Okay, so here children, what we have is we now have this question, and this could have been done more quickly, but why I have taken time is because I've taken pains to explain every point where I found that you could have had a problem. Okay, so in this question, children, we've been given here that we've got to find out the general solution of theta, which is the angle here, as this now is not a normal equation, it is a trigonometrical equation. So next what we do is we now talk about this to be 3 tan theta written as sine theta upon cos theta, because we've got to reduce these 3 variables to be just now lesser number of variables. So cot theta can be written as cos theta upon sine theta, and cosec theta can be written as 1 upon sine theta. Further then, as we have fractions, we'll be taking an LCM. The LCM will be the product of cos theta and sine theta, as they are 2 different numbers, and then we will have 3 sine square theta plus cos square theta. Since we know that sine square theta plus cos square theta is equal to 1, as such, this is going to become equal to 2 sine square theta plus sine square theta plus cos square theta, that is 1, that is 2 sine square theta plus 1, and rest of the entirety is the denominator, and the other side will remain to be the same. Now here, children, you are actually pulled in to be cancelling off the sine theta, but you shouldn't be doing it, because if you cancel off the sine theta, which will give you one of the roots or which will give you one of the zeros, as such, that is going to be lost. And I showed you by this example, if you have an algebraic equation where you have the privilege to be able to cut the common variable x from both the sides, then you will lose the value of this x. As such, you can't do it. Now if you have this equation, that means you must have cross multiplied the terms to both sides of the equation, and then you have it. Next, now you bring every term to the left hand side, and you find that sine theta can be taken common outside from both of these terms. Inside we are left out with 2 sine square theta plus 1 minus 5 cos theta, right? So next, now we have the product of both of these to be equal to 0, so we apply the zero product rule. As such, we say that if we have a into b to be equal to 0, then either a becomes equal to 0 or b becomes equal to 0, right? Telling that both a and b are 0 is something which is immaterial, will give you an absurd answer that everything is 0. That's not possible, right? So next, now what we do is we now go ahead with the first value, that is sine theta to be equal to 0. If sine theta is equal to 0, then what will happen? It will be 0 only when it is sine 0, right? So here we can quickly talk about these 4 quadrants, and you get to see that if you talk about sine at 0, it is 0, and similarly if you talk about sine pi, even at that point it is 0, because there then a formula is applicable that I'll tell you now. That is, if you talk about sine of 180 minus theta, then that, children, is equal to sine theta, right? Now here in place of theta, if you write 0, again this will be sine of 180 minus 0 is equal to sine 0. That again will become equal to 0. As such, one of the values which is also possible is going to be 180. Now 180 can be written as how much? It can be written as just pi. So pi, which is another value for 180, is another of your principal values, right, which I missed out. Excuse me. Now somebody is asking, why are you burping so much? So that's because I've had an awesome lunch, right? Always make sure that your lunches, your dinners, for that matter, every time you eat, it is always in the ratio of 3:2:1. 3 has to be carbohydrates, 2 has to be the proteins, and 1 has to be the fats, like the different oils with which your food is cooked. And if you do it that way, you will have lost a lot of fat, remember, and thus reduce your weight and start looking very good, right? And for that you can compliment me. Okay, now children, here we have this, that is, we've got another principal value, and it's not just 0, but there's another value which is pi, that we can write with this, and here we can write it as, I'll rather rub this and write it again. So one of the principal values that we have here is how much? It is actually one that was already found out, and the other which is pi. So these are the 2 different principal values, one 0 and the other pi, right? Now after this, children, we now next talk about the general solution. And remember children, when you have sine theta to be equal to 0, then theta becomes equal to n pi, and this gives you a general solution. And remember children, here there is one thing, that if you want to talk about the values of n, you will remember this, that n is an element of integers. Now what is the set of integers? That is, it is something like -3, -2, right, -1, then you have 0, 1, 2, 3, and all of that continues up to infinity, and here too all of this continues up to minus infinity, right? So this is what the set of integers is, and this is how you will be able to get the angle theta. Now this is a general solution. Now after this, we now talk about the other part, that is 2 sine square theta minus 5 plus 1 is equal to 0. And for that, when that is equal to 0, we now apply this trigonometrical identity, that is, if sine square theta plus cos square theta is equal to 1, we will be able to get to the value of sine square theta to be equal to 1 minus cos square theta. And in doing so, what have you done is you've converted two trigonometric ratios to be written just in terms of one trigonometric ratio, because sine square theta will now also be in the form of cos. Now when you multiply this 2 within, you will get 2 minus 2 cos square theta. Now 2 plus 1 will become equal to 3. Now you write the terms in order of descending powers. So you have minus 2 cos square theta minus 5 cos theta plus 3, which is equal to 0. Now here children, if you try it out by adding the two coefficients, that is the coefficient of the quadratic term and the constant term, 2 plus 3, so that will give you minus minus, and thus there will be 3 minuses and 1 plus, which won't get factorized. As such, what you'll do is you will just talk about writing this to be 3 into 2, which is 6, into 1, right? This is a measure which you normally take when the normal measure doesn't work out. So here you can write this as minus 6 plus 1, and thus you will have two terms with positive, two terms with negative, which actually can be factorized, right? So out of the first two, you can take minus 2 cos theta to be common outside, and then you'll be left out with cos theta plus 3. Now when you write cos theta plus 3, this will go how many times? This will go plus 1 times, right? And now if you take this cos theta plus 3 to be common outside, you will just be left out with minus 2 cos theta plus 1 inside, right? And if you write the product of both of these to be equal to 0, right, then what will happen is you can again apply the zero product rule, and you say that when cos theta plus 3 is equal to 0, then you will have cos theta, which comes to minus 3, and this is an absurd value because cos theta varies just between minus 1 and 1, remember. Now next what you do is you will talk about the other value, that is minus 2 cos theta plus 1 is equal to 0, and when such is the case, you will have minus minus getting cancelled from both the sides, and cos theta will become equal to 1 upon 2, and that is the time when you remember the angle 60 degrees of pi by 3, so cos theta will become equal to cos of pi by 3. So here children, we will get some principal values, rather two, the first being pi by 3 that we've already got, and the other when we talk about the fourth quadrant, where again cos is going to be positive. So if we talk about the formula, then that is cos of minus theta is equal to cos theta. So if you talk about cos of minus pi by 3, it should come equal to cos of pi by 3, which is 1 upon 2. So the other principal value is minus pi by 3. But as you see, we are wanting to talk about the principal values from 0 to 2 pi, that means only in the anti-clockwise direction. That means the angle should not be found out in the clockwise direction, but only in the anti-clockwise direction. So if you talk about this angle is actually 60, and as the complete angle in this quadrant is 90, so obviously this angle must be 30. And as this is 3 pi by 2 in moving from this horizontal line to here, so if to 3 pi by 2 we are able to add 30 degrees, then it will give us this principal value. So now we do that. Now we have the LCM to be 6, so this becomes equal to 9 pi plus pi, that is 10 pi by 6. We have a common factor 2, so 5 pi by 3 is going to become that value, which is another principal value for the solution. Now we talk about the general value of theta. For that, you can talk about when we have cos theta to be equal to cos alpha, then theta becomes equal to 2n pi plus minus alpha. Now here children, what you do is if you talk about the general value, you can have thus theta to be equal to 2n pi plus minus pi by 3, although pi by 3 can also be replaced by 5 pi by 3, but normally whichever is the angle in the first quadrant is normally considered, or whichever is the value which is the first negative value, which gives you the first negative value in moving from the first quadrant to the fourth quadrant, is considered in writing the general value, although both will give you two different answers, right? Okay children, so this is all that was there in this lecture. Have you been able to understand what trigonometrical equations are and what is the tact that we use so that we can solve it out? Yes? Are you finding yourself to be fully confident? Now, this lecture came out to be a long lecture. That is because I go about telling you about all the fundamentals. I ensure that I provide you a repetition of the concept so that there is nothing which is left out. Once when you are fully confident about the principles and the concepts which are required to do the sum, then I go ahead with the sum, give you a little time, discuss the sum, gradually solving out the sum also, and then further give you a second explanation. All of this actually gives you a wholesome experience, and you should take this complete wholesome experience, and when you do so, then everything will be clear. But after this, also remember that you have to pause the lecture and write the sum and do it all on your own. And if you get stuck up once and you've got to look up the solution, then do it once more. I normally call it class work done again. If you do it this way, then you will get excellent marks, and your logic will really open up, and you'll be able to remember the formulae and the concepts for a very long duration of time. So I hope I have been able to provide you proper service in understanding trigonometrical equations. Now I expect a few things. The first is that you should have done the class work done again so that everything is properly understood. Now you should be capable to be able to explain things now to your friends, become teachers to them, right? The next thing is I expect you people to write a simple comment as to what were the things that you learned from this, and what more you'd like me to do for you so that I can help you out to be very good in mathematics, right? So obviously, I'm sure if you're there till the end of this lecture and if you liked it, there should be a like, right? And there's also a share button. Share it to your friends who require help in trigonometric equations, be it in your class, be it in your school, probably in any other school or city, right? Now the onus lies on you, because I want to reach 1 million children and I want to remove the scare of mathematics to dust, right? Now children, if you really want to fast track your journey, you know that understanding each and every concept and everything is going to require you a lot of time, and for that you also require the time of the teacher who in person can teach you, right? And many other ready to learn courses are there which you just have to pick up from the shelf and start studying at your own pace, right? For all of that help that I can render to you, you require to just do one small thing. That is, you got to fill up a form that is there in the description, right? Just above the videos, you'll find that there are few links. There's a form link, a Google form link. Fill it up, right? Tell me what your problem is, and then you'll find me coming to you and helping you out. Remember, when you ask your problem now, you get confidence now. But if you ask your problem after 1 month, then obviously you are dealing this 1 month for which you will now actually be in a state of tension, depression, when you won't be able to do things, right? So the best help got is if it is got immediately. Just think yourself as a patient who is there in emergency. If that patient requires oxygen, it doesn't have to be provided to him after a week. It has to be provided just then. Otherwise, after a week, you'll probably get his name in the mortuary, right? So make sure, children, that you fill up the form, get your help, and I'm just sitting here to help you people out. So make yourselves the best derivatives of yourselves in mathematics, and I'm going to push you so that you can get 100 in your upcoming examination, or probably 100% in whatever competitive examination you are sitting for. Bye children, waiting to help you people. Bye.